interested in is how are we going to teach robots? But if we don't know what we are experiencing, how would we be able to teach a robot? It's not possible. So one thing is, my job, I'm interested in quantifying our experiences. Not only to immerse into the virtual world, or meta world, not the most popular word now, but be able to actually relive the experience. BTS just made a concert last week, and that is a huge party for everyone in the world, everyone I'm using roughly. Why do they come all the way here to listen to the concert? Why? Apparently the experience is different. You can smell the sweat of people, you can feel the vibration of the speaker, you can feel the heat from other audience, you share the energy. Can you tell AI what that means? Okay, remove that experience. There's a joke in Korea for many years. I don't think it's still a joke. They say, 교과서를 배워서 글로 배웠어. If you tell your friend, oh, I'm going on a date for the first time, or your little brother, little sister, and they're nervous, I don't know how to kiss. You try to explain it to your friend. You tell them how to kiss. Are they gonna get it? No, because they will be 글로 배웠어. So if you don't, and that's how we're teaching our AIs now. You're 글로 가르쳐. You're teaching it through text. How are we gonna go beyond text? For me, we need to recreate this experience. I'm not saying we're going to recreate robots who do the kissing, but we are going to be able to quantify at least interaction forces. So the idea is we have chosen experience, whether it's a concert, skiing, surfing, sailing, or even meditating. We have a certain analog to make an experience filter, and have a haptic interface to relive the experience. Of course, it depends on how many user friendly you create, but it's going to be relative to whatever the experience needs to be. And we have already decided we're going to pick out the abstraction and the energy of experience, the immersion, how much immersed you are to the image or the experience, and then the interactive, bi-directional. So not only you see and you experience it, but as you experience and you give your force, the environment changes. That's what I'm interested in doing. And so this is one of the first trials we did. So Francesco needs to be out there, but what he wants to show is his foot is giving the different force input to the load cell, and he's controlling already the mirrors to go in the direction that he wants to go. So we realized it in the Unity, in the physical engine, and then now we are actually exploring the same level of interactivity on a ski slope that we capture from the satellite. So from the satellite image, we know which slope is going to go down, and the topology of the mountain, and we were able to experience the mountain on a snow slopes. We were also able to update the friction of the type of the snow. Obviously, we're not going to feel the G-force on the chest because we don't have the straight rail line, but we were able to control and feel the acceleration of the curve. Same analogy, we can actually extract the images from the video from the ceiling. So we're on the boat, we take out images, and you can go through the exactly same seasickness on the board as well. You're reliving the experience, and you're able to also control the direction of the boat. And using the same analogy of an immersion formula, we extracted also the music. And so this is Amy Winehouse's music, and you're extracting not the beat, but the energy. So it's a combination of the beat, loudness, the richness of the melody to actually create the different amplitude and then the acceleration and the rotation. And combining all these three, we can actually create very, very immersive experience. It's not immersion from your goggles, because I hate goggles. It's not based on vision only, but you're combining this with actual physical experience where you are injecting your input. And that really gets you excited and you actually feel the difference. This is examples of a kinetic feedback. For us to, kinesthetic feedback, when we actually mentioned about knocking on boards, how it goes up your bone, your vibration, and your brain registers it, this is an example of kinesthetic feedback. For you to really understand the experience, you need to also activate the skin level, the cutaneous feedback. And you must be able to combine these two to actually feel the difference of what's happening with the world. This is an example of how we're creating cutaneous feedback combined with kinesthetic feedback. The reason and then how we do this is actually decoupling how far your finger gets dimpled into the silicone. You saw with the example of the marble pillowcase, you only feel things are soft if your finger skin gets wrapped around by the material. It does not matter how strong, how much distance you travel based on the force you put in. That's the material hardness, but it does not equate to the softness you feel. So by actually modulating the cutaneous feedback on the skin, you're able to recreate the feeling of marshmallows and silicone, of foams, and things like that. And the next work, this is done with a Professor Kim Sung-wook here at SKKU. This is an example of how you're able to use this. This is non-cutaneous, but having very special sensor, very active sensor, super sensitive because of all these pyramids. We're able to create a shear motion or feel the shear motion directly onto the sensor. So pressure and shear. And if you combine this with the origami platform, you're able to actually manipulate and modulate the reactions of the transmission on the bottom. And you're able to understand the object size. That gives you feedback directly to this bi-directional joystick, give force, gives stiffness change with modulation. And that allows us to actually interact much more immersively to any screen that you see. So for example, if you can use this as a cursor to flip around between your Instagram feed, but also you're able to, see, so you're doing shear, and you can actually feel how hard the marshmallow is, how soft the sponge is, how strong this super ball is, and different erasers. And this interaction will allow you to not only be immersed, but open up the understanding beyond just images and screens. So hopefully, these three pillars I introduced to you, matching the spatial functional resolution through origami and modular platforms, matching environment compliance either through materials compliance or the compliance of the design. And the third, matching the expectations of the screen by quantifying our experience allows us to actually have more intuitive and intelligent solutions toward not chatbots, but actionbots in the near-term future. So for you who work on the robotics, through materials or design or control, I think it's super important. How do we understand the quantified interaction force? We always talk about human in the loop for the solutions that we're talking about now. No one talks about, we don't want human in the loop, we want to have independent solutions. That was called automation and industrialization. As a researcher, we have to be aware of how humans get into the loop, not only in the design phase, but in the control and as well as the operation phase. So having the humans in there requires us to understand what is the quantification of this interaction. And then hopefully these can serve as a building blocks for us to design the next generation automation.